Yeah. So I need some help to move my slides to the projector. So good morning, everybody. My name is Manolis Vavalis, and I'm a professor of electrical and computer engineering at the University of Thessaly. In my life, I was lucky to have excellent teachers, good students, and excellent collaborators. I've been collaborating with Christos for more than 20 years, and the objective of my talk today is to let you understand what kind of scientist and person Christos was. I've been collaborating with him on many projects that had Greek names: Ephesus, Pliades, Arion, and several others. And this reflects the love of Christos for his country. That was the reason that left IBM, came to Greece, and divided his salary by 5 or 10, somewhere around there. Not only he knew the acronyms, Ephesus, Pliades, and Arion, but apparently he was very knowledgeable about their deep meaning. That's culture on top of science, and we should all appreciate that, I suppose. I'll split my talk into 2 basic parts. One, the years that we worked together here at Heraklion. Christos came here from IBM. I came here from Purdue University about the same time. And at that time, I called these years the Pliades and the University of Crete years. I first met Christos as a steering committee of the very prestigious, at that time, computer center of Joint Computer Center of the University of Crete and Forth. Let me give you the scientific climate at Heraklion at that time. We had a new university attracting excellent scientists. We have a brand new research center, unique in Greece from many respects, and we had a government that had money at that time and strongly supported research and development. So we were all super excited, and we all worked in a very appropriate way. So as I said, I was a member of the steering committee, and Christos was the chairman of the committee. And we started developing supercomputing facilities. That was the Power Challenge SGI era, as you probably know, and we had such facility at the University of Crete, a small one, but fully utilized. At the same time, we were both with Christos members of the national effort to build the first Greek supercomputer, to make it operational. It took 20 years for us to actually have the first computer, supercomputer, that is in the top 500. I think now it's top 400 on the Bucharest list. And in the next few weeks, we will have this available to the Greek community and the European community. And part of the success during heavy recess time is due to the efforts that that committee invested for almost 20 years. It's not extreme to claim that Christos has an impact on this first Greek supercomputer. Just right after his establishment in Crete, Christos created the Distributed Systems Lab under the name of Pleiades, and that belonged to the institute, very successful Institute of Computer Science, the fourth, and he was the chairman of that, director of that laboratory for 4 years. He left to become the president of the University of Crete. Pleiades was the name, and that having a lot of meanings, you probably know most of them. What you don't know is that there's so many projects that Christos and his team were successful to get at these years. It was much more easier to get funded from the European Commission that year, but we were struggling to accommodate the so many projects. Extremely successful 5 years. I'll mention here 2 of the projects. Aurora, I'll try to be as less technical as possible. Aurora was a project that I didn't involve myself. But I know that Christos was speaking very proudly about this first project that got funded from EU as a distributed system laboratory director. I highlight the fact that the whole system, World Wide Web, Java-based and Colpa-based, that was the technology, I think it's 1995 that were in business at that time. But the vision that inspected and manipulated at that time inspired many of us, including, of course, myself. That was not very clear in 1994, and it was not well accepted for let's say, narrow-minded scientific people, but had a strong impact to many of us. On tour was another project, nothing very special compared to the pleiad of the other projects funded by the leadership, under the leadership of Christos, but it contained the notion of workflow very heavily, and if you let me comment here, that Christos, as you will see, were open to many thematic areas. Not at all narrow vision and not at all staying in one discipline. At the same time, he was very, he was standing on strong basis, and you will see similarities from my talk with Professor Vignoti's talk. He was moving from scientific area to scientific area, but always on strong background and with very careful steps. So On Tour was a project that applied workflow technologies at runtime also, similar to what Professor Vignotis mentioned and will convey. What is Retour? Retour is an ongoing project. I've been invited 3 years ago to write a proposal. It was ranked first and funded, of course. It had to do with creating a new market and a new information technology framework for remedial and rehabilitation tourism. Big money are in there. We haven't seen them yet, of course, but it is a very open and underdeveloped market. I should tell you that half of the proposal that I wrote was taken by the proposal that we wrote with the work wrote on tour. So the work that Christos has been participating is clearly characterized by the fact that it always remains fresh, and that, as we all know, is very difficult in our thematic area of information technology. So Retour is very successful, and in fact it is part, although Christos didn't participate, it is part of Retour that Christos led. Christos also, I always wondered how he managed to do so many things during the first 5 years at the University of Crete, was the SIM Executive Committee Chair during very important years. The years that ERSIM was moving from a baby organization into strong, widespread organization. We well know that they are hosting W3C headquarters and so on. So he, besides being an executive committee chair, he was promoting ERSI News, was the main driving force behind ERSI News, and participated and affected strongly other areas and activities. I was involved in the ERSI working group with Christos on environmental modeling. Here you see again how Christos used to have the ability of moving from through diverse thematic areas and R&D activities. Environmental modeling also involved workflows, data organization, metadata organization. We went into knowledge management, and we still are, and of course real-time and service view. The last project I collaborated while I was at Crete with Christos was Information Cities. Information Cities was a FED project, and you should know that I consider FED as the most appropriate R&D funding instrument in Europe. Christos was, it is not known, but it was an active consultant for the FED at its early years. Now FED is widely accepted, and every FED project is very prestigious, and Christos strongly contributed to the development of the FED product, of the FED system. So Information Cities, I think Ramesh will talk more about this project. He was deeply involved with that with Christos. I was also participating as, in fact, the coordinator of the project. Christos, right after the beginning of Information Systems, was elected the Dean of the University of Crete. So I replaced him as the project coordinator since administering a Greek university is, you can't imagine how much effort you should put on that. So he left essentially Information Systems quite early, or in the middle at least, but he wrote the proposal with the other colleagues, of course, and he ran the first steps with it. I highlighted again, not going into the technical details, but I highlight a few words: virtual world of info inhabitants, and billions of info inhabitants that meet or operate and trade. Stable and scalable microenvironment. These are words and visions that are still valid, and although Christos transformed a little bit, viewing the info inhabitants in an extended fashion as a cyber-physical world. I'll talk about that later on. So I'm proud to be part of the Information Cities, an excellent project, state-of-the-art, excellent people, stellar reviewers, and that closed my first period working with Christos. I moved to the University of Thessaly, and I left for self. We were trying to establish a new university up north in Greece, and Christos was very busy, again, administrating the University of Crete with all the problems and fun that this might involve. So, after stepping down very successfully as the president of the University of Crete, he quickly moved into heavy R&D. When I say heavy, I really mean it. He developed the new lab within the University of Crete, and he was equally successful, although the competition for project funding was much more tougher than the distributed system laboratory years. So, with TSL, the Transport Service Laboratory, we've been collaborating very closely on several proposals. I should say many proposals, and I should say many mostly unsuccessful proposals. It is the characteristic of Christos, not how he dealt with successful, but how he managed failure. We failed several times, as most of you have failed, I suppose, on attracting funds, but the way that he was accepting the failure and funding, it was truly amazing. And I'm glad that I went through several failures with him. We went through several success stories too, and one of them is the Ephesus project. It was ranked top, I don't remember, top 5 out of 70 projects, and it involves our efforts towards next generator intelligent energy systems for Europe. It is a collaboration between 3 institutions. Fourth now, I was not involved, me and Christos were not involved before, so CERT was the leading organization together with my university, the National Technical University with its electrical and computer engineering department, and of course TSL from here. You may miss it, but Christos was trained as an electrical engineer. His degree was electrical engineer from the National Technical University. I do remember during our kickoff meeting saying that I forgot everything about electrical engineering. I only remember that there was a sign of ambition involved. And he was honest. Next meeting was in 6 months, and Christos was communicating with our energy and electricity experts fluently in their own words. So he was interested, true interest on what we were doing, and he was very capable of recovering knowledge and communicating appropriately. So, I'll give you a few details, not technical, about Ephesus, but are, I believe, related to Christos' scientific figure and activities. Christos, as I said, loved Greece, and but also he was very pleased with his stay in the United States, and in fact he never left USA, emotionally or practically. He was visiting, and in fact his daughter is in USA right now, and he was planning to take his sabbatical there. And during Ephesus and with Christos, we were focusing on the success of the regional operation of energy operators in the United States, Eastern Coast. Up there we see a consortium, a loosely coupled market of 17, if I remember, different local operators, buying and selling, distributing, and transferring energy through half of the energy in the United States. Local markets with very different pricing signals. The price in Rhode Island might be 3 times the price of Ohio, and PGM is a very successful practical energy integration and operation example. So me, Christos, and the other colleagues were inspired by the practical success of PGM. We don't believe that we have such success in Europe. Situation is completely different, but we were thinking this as a basis. So cooperating local markets that are based on strong grounds. To achieve what we promised in Ephesus and to bring the US practice or success story to Europe, we've been working in a multidisciplinary fashion. And that's where Christos was very good. So, what means multidisciplinarity? Besides IT and electrical engineering, of course, it involved issues that affect energy grid systems. That means powerful equations, Kirchhoff laws, Ohm laws, and adjacent lines, mathematical models of electricity and electricity, power generator equations. Marketing model. Christos was much more familiar with that, but the way you market energy differs a little bit from the way you market other things. We're not sure if it's a commodity or a service. It is complicated, to say the least. So you track it in many ways. First, you model it through differential equations. You consider the stochastic perspective of the whole thing. You end up with an optimization problem, a very complicated optimization problem. And then you have solvers from the game theory. Professor Viniotis already mentioned the interest of Christos on game theory. So he is using this tool for many years, and he was collaborating with our game theory gurus from the National Technical University of Athens very nicely. Heavy scientific computing and numerical analysis stuff and complicated optimization problems. He was absolutely not afraid of mathematics, something that is not true for many of my colleagues from other disciplines. What Christos was very good, of course, is the technological aspect, and you see here that Ephesus involved several enabling technology components. This is from the power distribution simulation framework was developed by the National national laboratories in the United States, open source, very steep learning curve, and so on, then we are obliged to to follow the technology platforms imposed by the European Union and the companies involved, and we fully respect the EU technology platform for electricity networks of the future. Then aging framework is needed, and feedback is what we based on, and of course W3C with the web services and so on. We have been integrating all these technologies, and Christos was very keen on that, and he was playing very actively. Ethos is based on three very simple assumptions, and this is the last part that I'll bother you with, sort of technological issues. And the first assumption goes as follows. We are not, with Christos, we were not electrical engineers. We were not doing R&D in electrical engineering at the time we proposed Ethos. Other partners did, but we know very well. We were quite familiar with what happened on the internet and the information technologies, the information markets, and so on. And we were trying to transfer our knowledge and expertise to the power grid. Of course, there are big differences. And the main difference is that the one, internet, is demand-driven, and the energy is, I think it's the other way around, demand-driven. When you request the energy, so switch the red flags around, and that's a huge difference. Another difference is that you need to have stability in the power grid. And we wonder how the fully distributed, absolutely uncontrolled compared to the power grid, internet is so stable within the framework. And buffers seem to play a very important role in the internet. And we start the idea of developing virtual buffers for the power grid. Physical buffers are not possible because batteries, we'll talk about batteries in a minute, batteries are quite expensive to play the role of the buffers as they were in the internet. So we developed the concept, and we're still working on it from the practical perspective on how to have virtual energy storage, the virtual buffers that needed to stabilize both the power grid and its markets. We think that if we have an intelligent management of the and sharing information, this will lead to scheduling schemes, intermediate scheduling schemes that will create virtual buffers that view as virtual as batteries from the consumer viewpoint, and therefore develop these virtual buffers. And I think we are moving pretty successfully in that direction. First assumption is this one. Second assumption is that the price elasticity can manage stochasticity. Christos was very clear about the difficulties that came with the double stochasticity involved in the power grid. There is stochasticity from the consumer viewpoint, so you can put the button on anytime you wish, nobody is going to block it. And there is also now stochasticity from the producer's side, since wind goes on and off and sun goes in and out, and since a big amount of our total energy comes from renewable sources, this is on one side good, but on the other hand, it imposes stochasticity, to say the least, from the producer's viewpoint. We don't have a power plant that always work steadily. This double stochasticity is a difficult problem. It is a view here to practice. What we have in this picture is the PGL, United States big operator, and specifically the New York Bay, and February 2 years ago, and we see the wide variety of the marginal prices. Something that you don't expect being in the current grid situation. Here, we present the 120 hours demand and response that we, figures that we expect from the smart grid. So the smart grid tries to smooth the variations between peak and off-peak hours. And we need to do that in practice. And we're quite successful on this picture. Currently, if you don't use smart meters, then you have steady power supply at the peak demand. Now, you can control the peak demand by predicting the peak, the demand every 15 minutes or every 5 minutes, and accordingly adjust the cost of the megawatt hour. These, in short, are the pricing signals that create the price elasticity, which can manage this double stochasticity, which is a huge problem. That was second assumption. Third assumption, I will not spend too much time on that. Batteries are in our life. Electric vehicles are approaching, or are here, but are heavily approaching. So we developed within our own scheme that uses the batteries for two stability reasons: power stability, no blackouts in some sense. We use them as more buffers, and of course as market stability. So we consider the integration of the physical storage that stabilizes the smart energy. And at the time we started, Tesla Powerwall was not available, but now we can get 10 megawatt hours with a decent amount of money, and energy storage is a big issue which we study in Christos. There were things that we didn't consider in Ephesus. So we didn't consider very important issues. Small project, relatively small project. Energy behavior markets and economics. Subject that Christos was very fluid and had very interest. Another interest is trust, awareness and privacy. And I do remember 15, 20 years ago organizing international conference, very successful international conference in this building, focused on trust. So how do you trust? How do you make the consumers aware of the market issues, energy market issues, and how you help them sell their privacy for better electric power prices. It sounds very capitalistic, but that's the situation that we live. And we also consider, we didn't consider energy union, whatever this means. It is a very hot topic in Brussels nowadays. So the things that we didn't consider in Ephesus are the things that we were working with Christos in terms of new proposals and other more specific activities. And unfortunately, we have to go without him. And unfortunately, that interaction started very in a very sad way. We had a meeting at 12 o'clock for preparing a proposal on these issues, and Christos died at 6 o'clock. So I was very happy to meet Christos. It affected my life, and Christos Nikolaou's life, and many other lives, and we will miss him.